All right, after a long night of wiring, here's where we're at. Starting to look a lot better. Got the headlights all in and cleaned up, and they're looking phenomenal. Looking real good. I forgot how good those halos look on these because these are higher quality. They're a little brighter than some of them. One thing I ran into, I noticed before it was hanging around 3 psi. Now this carburetor, it needs to be around 5. You can do 5.56. 5 is where you really should be. So I got to figure out why it's not building enough pressure, because that does affect how well the jets work on these, because these are bolus carburetors. So you need to maintain constant fuel pressure for these. So I need to work on that. Got the fuel pump connected. I'm gonna go ahead and start it. See, this is how it used to run. It used to just start right up like this. And I'm pretty sure it was the ballast resistor that was the real issue, as far as like having to turn it over quite a bit to get it running. But it's also smoking a little. Hard to pick that up on camera, but that concerns me a little bit. I'm gonna clean the plugs and everything, but sounds good. It's just smoking. I don't really remember this burning a lot of oil or anything, so that's going to be something I'm going to look into on this. Of course, right now it has a mixture of like stale and good gas. You can see it ain't even up to 3 right now, and I already have the regulator loosened, and I'm adjusting it. Really ain't creeping any, which ain't good. I think what that's going to mean is I'm going to have to flush it or check the filter, see why we're getting a drop in pressure. Also, I went ahead and checked the exit temperature, made sure the thermostat was opening, checked the alternator. I clamped the alternator. Um, Tell me my battery's dead on this thing. So, and this is actually high. It should be, closer to 13.5. And, I've had the maintainer on it, so it really shouldn't be spiking that high. But it's not really concerning me yet. Now, when I clamp it, it's outputting like it's supposed to. You can see right here, 10, 11, 12 amps, which is normal for just the battery, just maintaining it running and everything, charging the battery a little bit. But I'll keep an eye on that. But yeah, everything's going good. I still haven't buttoned up this yet, but all I have to do is add another relay and another fuse, and that's it up here. I mean, the rest of it will just be for like expansion another day. But man, I can't get over how great these headlights turned out too. You can see it a little better now in the daytime. You can see that yellow. It just really sets off these classic cars when you run halogens, because you still get a little bit of that incandescent glow, but it's not, it's not, so yellow that you can't see at night. And you can see how I got these nice and hidden, the turn signals. Those are looking good. It looks really sharp in the front now. I think what I'm gonna do is maybe hit all the rust on the body with a slap disc and put down some epoxy primer, and then I will try and match this flat hot rod black. I do have some, but when it comes to paint, if there's already paint on the car, it can be extremely difficult to match it and have the color tone turn out correctly. But I know I have some hot rod paint in here somewhere. Base black with reducer. I I swear I do though. I have a whole thing of hot rod black somewhere, and I still have epoxy primer, but I bet you it's all separated and it ain't gonna work now, unfortunately. So I might have to just pick up some. I do have some Bondo and some VHT and stuff. Uh, so I might touch up the headers and do some body filler on the outside if that's any good anymore. But that's where I'm at right now. All right, so looking at this, um, right here, I'm gonna pull a ground from the body up just for the panel. A nice ground. And like you got wires like this, like why would you have red ring leading into black? That's not good. But this actually looks like it's a. Wait, that's a. What in the world? Because your yellow is your. This one, oh, okay, I see. So for whatever reason, this radio company put markings on their positive and ACC wire and stuff, which is odd because normally it's only the speaker wires that have a stripe. So when you see that, it's like off-putting, but no, I guess that's correct. And otherwise, it wouldn't have turned on earlier. This one's a little weird. A singular, like pinkish almost. Looks red on camera, but this is actually like a pink color. This is red. And I guess that's supposed to be ACC. I don't see any reason to have all this. I don't know. We'll see. And then the fuel over here, I've decided, of course, I'm going to do a relay but up front, but I'm going to probably reinforce the ground. So we're going to ground. That ground is going to go to the grounding point up here, and it's going to keep going through the firewall back to the fuse panel to relay center for its ground. And then this one will be for positive, of course. And then that still leaves these two, which, if you remember, I have to tie into these. One of them's going to be for halo, and the other one was going to be to trigger the fuel. So you got your fuel trigger, halo trigger for the relays, and then you have the actual positive and negative for the fuel pump that's coming in here. And yeah, that's where I'm at. So I had to run some extra wires. I ran another one of these, wasting some more of that blue wire. Couple positive, negative, and then a spare. And I was trying to decide what I wanted to do with this. I don't know if maybe I'm going to have a relay for the switch panel in here, or what I want to do there, because here, technically, there's no fuse in between, because I'm not going to tie into the factory harness, so there's no fuse in between, the standard functions of this. So the part that feeds the positive, that's going to actually power the headlights, the relay for the headlights and stuff, and then the voltmeter that's on here, and then the lights. So these have a running light, more or less like it's supposed to come on when you turn on the light switch, like for your parking lights. These would light up, your interior dash lights would light up, etc. I don't know that I'm going to do that, because I don't know if it makes sense for this. So I think what I might do is, which side's up on this thing? This side's up. So what I might do is use the keys ACC wire to power on the lights for the fan fuel and fan. That way it's like a reminder. It's like, hey, these two blue lights came on. I should probably turn these two on, right? Before I try to crank. And then what I might do is the radio one will power the other lights, right? The regular blue lights. All right, so I've got the ground all sorted for the fuel pump. So this will be, that's the supplemental ground, and then this is the chassis ground. Only reason why I ran a second ground is just I wanted to be sure I wasn't going to have any problems. Plus, it's going to backfeed the other ground just in case whatever painted piece of metal this is. Make sure it's always going to have a good ground I just want to point out something else too. You'll notice if you do electrical in older vehicles, the newer wires and versus the old wires. Now this is copper. This is 16 gauge, I believe. It matches the source, but you'll notice the older wires are actually very stiff, and the newer ones are flexible. Now that's because this isn't pure copper. This is an alloy. It's copper mixed with some other stuff, and it's more flexible, but it's just not as good as the old wires. Nothing beats the old. Even the sheen of the pure copper, you can tell the difference in the two. This has a deep, richer look. This wire's fine and it's going to work fine. One thing I wanted to say though is when you're buying wire, do not get the copper cladded aluminum, because if you do, you're going to have to step up in your conductive size and it's just going to mess everything up. So get an equivalent copper wire when you're doing this stuff. Another thing I meant to point out earlier, um, on your 80s vehicles and newer, you'll notice a lot of grounds go here, and it'll have a stud that comes out further. It's just for grounding. It's a pretty common thing to have the ground right there um, on the steering column. On these older, the 60s, they're not there. That's still a good grounding point, but I'm not going to use it, especially because this column's kind of loose a little bit. I want to get all that straightened out and not have any wires in the way. The idea being, under here, when you're finished, all these little holes and crap that are in here from where people try to put little wires in them over the years, leave all that alone. This dash piece, and then you can come in with the flat piece of metal, make it look nice. You ain't got to worry about like a ground getting in the way or something. Make sure you're grounding it up into something that's recessed up into the firewall, and check and make sure it's an actual ground. Um, and I didn't explain this tester too good before, but if you pick up one of these automotive probes, when you're using a multi-probe, there's a lot of different options. I don't remember the name brand on this, but it's PP-1V5. This particular one's 12 volts. Um, the way these work is you've got a pigtail that goes, you're supposed to connect to your battery, positive and negative, and then you have a supplemental ground here for when you're trying to power the device to do some testing. So you'll notice you can force the probe to be positive, you can force it to be negative, or you can leave it as a probe and you can actually see what something is. This comes in real handy. We were talking about relays before. Here's one of the old relays. Now I can take this relay, and if I add power using the probe to 85, 86, you'll hear the relay click. So we're going to do that right now. Move this here closer to it. We'll go ahead, and now since it's a coil inside of these relays, they're technically not polarized, but I believe 86 is supposed to be positive. So I've got my probe here, and I'm gonna be quiet. You see that it's currently ground. Now if I trigger, hear that click. So that just demonstrates how you can use that tester to test a pin out if it didn't have a diagram, or test a relay, just make sure it's good. Well, that's part of testing the relay to make sure it's good. After that, you actually should pull resistance. You should put your own meter on 30 and 87, which is, this is supposed to be your battery, and 87 is what you're trying to power. So you put your voltmeter on here and put it on ohms, and when you trigger these two, it should go down to 0 ohms or close to it. That way you know it's working good. All right, since this video's turning into a little bit of a tutorial, I figured I'd take some time to explain a few things. Now, I'm wiring the fan to a relay and a switch. I'm doing that because me and my uncle are kind of old school when it comes to regulating temperature of your vehicle, and he lives up in Michigan, so I'm already having to put in 5W weight oil, a little bit thinner oil for him. We really want to be able to crank the vehicle, get it up to whatever temperature he wants to get it to, and then he can turn on his fan. But also, people that have been hot rodding forever, we usually, when we do switch to an electric fan, we usually have it on a switch because, I don't know, it's just something about being able to crank your engine and not hear a fan roaring the first thing as soon as you turn the key. I mean, the fuel pump's bad enough, so. But anyway, These kits come with your standard Bosch style relay thing, and of course you'll know if you're getting a good quality one or not, because again, this isn't a copper cladded aluminum. This is actual copper. You have a nice brass fitting, not an aluminum fitting. It's been looks like it's been properly made and everything. So normally this would go into one of your temperature probes. And all it does is it works with this thermistor here. Actually, that's the thermistor, but it works with this to basically trigger the relay and switch the fan on and off as needed, based off the temperature. And these will come in different temperature ranges, and you can't just go out and just buy anyone off Amazon either, because you need to look at the temperature range and make sure that that's going to be the operating temperature for your engine, because if you run too cold, for example, you can have increased wear. You run the risk of your heat and defrost not working good. If you run too hot, then your engine might get too hot in traffic, especially when you're running aftermarket air like we have on here, which dumps a ton of heat into the radiator, and you're sucking all that heat through there. And so if you don't pull enough air and have a good high quality high amperage fan, you also will overheat. So keep that in mind. If you run your air and you overheat, it's not that your engine isn't working right or your radiator isn't necessarily working. It's probably that you're dumping so much heat in your radiator and you haven't done anything to pull enough air through to offset that issue. So moving on from that, when you're running basically a positive in here, usually it's nice if you just put in a little distribution block like this, so you can run your positive lead, which in my case has a fuse and a relay at the battery, so we're not talking about anything dangerous here. It comes in here, it's already fused, already on a relay. Then you have your positive block, and this would be like ACC more or less, so all of your accessories, radio, trigger your amp, and power the switches and whatever else you want to put in here. I'm not going to run this because we're not overly complicated here, but like if you're building a vehicle and it doesn't have a factory harness, or you're going to do a custom harness, you need to get some of these, because you would need them to make that work for you. So here's some of the gum I pulled out from under the dash there. So yep. All right, I wanted to point out a few other things. Carburetors come with this normally, and a lot of guys will throw it away with the tags and stuff, not realizing if you have an electric choke, you actually need this ground. Now, what ends up happening is sometimes they'll have a little grounding strap that goes to the bolt, or maybe even the little actuator might have a little local ground or something. But what ends up happening is this connection in between your carburetor and the intake, it has a gasket, and so it's somewhat insulated, and you can get like an intermittent connection. That's why they give you this. Now, this particular car had a manual choke, and so we have a manual choke carburetor, and you can see it's not connected. I'm gonna fix that up too, and I'll probably actually put a little bit of like grease and then shrink wrap right here, or maybe a little bit of oil. I'll wipe it off and then put some shrink wrap, kind of keep water from seeping into this cable, because what happens is water gets here and it actually travels all the way up the daggone cable, and it oxidizes the whole thing. And another thing I'm just now noticing, this is way too long. This should be trimmed. So probably gonna do a nice, beautiful, like round radius here, and bring it back in here, have it all nice and neat. I could probably even secure it right here, keep it from rubbing on the firewall. I'm gonna get that straight. And then I figured I owed it to some of you guys to show you the crimping and stuff, so I'm gonna show you how I do one of these, and I'm gonna point out something else for these relay boxes. You know, they come with spade connectors, and they come with ones that are made for the boxes. How it's got a little piece that comes up here and it catches into the plastic and stuff. So you want to use these And all you have to do is, you know, if you've already got a wire that's got one on there, just compare the two. If they don't look the same, then you need to change it out, because this might slip out. It's probably going to be one of those things where it works for a long time, and then all of a sudden you start having problems. So, and then you're going to spend hours troubleshooting just to find that that wire's kind of loosened itself and come out. So why not just do it right the first time? So when I'm crimping, I first get me a suitable shrink wrap that's going to go good with it, that particular size. If you put one on there too big, it ain't going to shrink. Put one on there too small, it ain't going to slip over the end of the crimp connector here. But usually I'll twist my wire and then I put it in there. Some guys will say you shouldn't twist, some say you should. It doesn't matter, as long as you get all the conductors in there and you fold these over. I pre-crimp, so I'll fold these over and I'll show you what that looks like after that. All right, I got my camera all set up. I'm gonna show you this crimp. So remember, starts bigger and gets smaller. The little point of these are supposed to push in on your crimp side, not your back side. So we're going to do that. And you can see that first crimp really didn't do anything. So I'm going to go ahead and move to the last one, which is the 16 gauge. It's good. I'm going to start one up for the part that has the insulated part of the wire on there, because you can see it already presses it in quite a bit. So we're going to, I can zoom in. I'm going to leave that one size up, and then I'm going to crimp the part that has the conductor at the actual size you're supposed to crimp it. And then we'll bring our little heat shrink up here. Bam. Now, I would suggest using a heat gun so you don't burn the wire like I did, but it'll be fine. Now, we're good to slip that in the back of the corresponding relay, which I think I'm going to do. Let's see, I'll probably do fuel here, fan. No, that's the fan already. We'll do fuel, and then we'll do halos here and leave those as one of those, and then leave the others as a spare. And this is one of the extra ones, so this could be the halo. This one I already have wired in for the fan, and then this new one I ran is going to be for the fuel. So I'll go ahead and do this one on screen too. And remember, you know, 16 gauge is fine, because all this is doing is triggering a relay. It's very low amperage. It's not actually powering the device. What's going to power the device is when the relay switches and it cross connects our bus bar that is going to the positive of the battery with the actual device. And there's, of course, there's a fuse in between. So this is the best way to do it, in my opinion. There's a lot of ways to do this stuff, and there's no book per se. I'm sure there are some out there. If you're anything like me, I'm not a big reader. You know, I learned a lot of computer and electrical engineering through self-study and going to school and things like that, and trades. But honestly, you're going to find things that work good for you, and you're probably going to stick to it, and there's nothing wrong with that. But you want to be safe, and the good practices you want to get down pat of, you know, having good crimps and using good wire and looking out for oxidation and neutralizing that anytime you see it in an old wiring harness. Get you some good crimpers and some basic tools. So like this is a Cobalt, and I have some more expensive Klein tools and things like that, but for my toolbox in here I just keep the basics that are from Cobalt, and they work just fine. So you don't gotta go and spend a bunch of money. These Piva brand, they're sold on Amazon, I believe, and it's made for a solar thing, but I mean, you can use any kind of crimper where these change out in different sizes and such. As long as you've got 14 and 16 gauge in there, for the most part, you're good. It's nice to have a little 8 gauge crimp too. And then if you get into anything bigger than that, you need to get the real crimpers that are made for crimping lugs and and large ring terminals and stuff, and I have one of those too. Get that one folded over, and I actually did this wrong, but it's good to show you. I meant to have the sheathing all the way up through this first one so that it can grab, but since it's a pre-crimp, I can just push it in there, you know, clean that up, go ahead and fold these over. Oh, and keep in mind too, a crimper will fold these for you. I like to do it by hand first because I usually prep a bunch of wires and then crimp them all at once and then do the heat shrink all at once. So it's kind of like a 1, 2, 3 step instead of doing it every individual wire. I'm doing a bunch of them at once because I already know what I'm doing and I already have the pin out and everything. So there's no confusion. But if you're doing it like this helps for whenever you're troubleshooting or doing something that you're not doing from scratch, because then you get to do one at a time and make sure you're keeping track of everything and documenting everything. So I got that one on there. Now the ground is actually going to go to here, which this is a grounding loop for the panel itself. So right here where it's mounted to the firewall, over here, this grounding strap's going to go in there. And it's going to loop under and go to this ground. And it's going to go to this dedicated ground that I pulled right here. Like that. So what I might do is pull an extra conductor from here to the actual very first negative crimp for the first relay, and then we'll, you know, daisy chain, because again it's just a negative to help trigger the mechanical part of the relay. They just need to share ground. It's nothing crazy, but this will back feed this ground to my fuel, and also ground it another chassis ground. So everything's grounded, everything's neat, everything has a localized positive and negative, and everything's real clear and easy to read or see what's going on, I mean. And you know, I'm going out of the way to put some heat shrink on here to help with the coloring, because I realize that this is blue and, you know, it might confuse people. But again, this isn't a rewire. This is basically, we're putting in a auxiliary harness, more or less. So this has been 2 days already, and I'm taking time to stop and take breaks and record and talk and do things. All right, and here's a double crimp, 2 wires. That's what it should look like afterwards. All right, so I made a little mistake. I figured I'd show you. I put these in the wrong spot, the negatives. See, that's pin 30. So that's actually, I knew, but when I turned it back over and looked at it, and that the one pin that's going in a different direction is pin 30, and that's for the actual load here. So I went and got one of my injection tools. This is another tool you probably want to pick up if you're going to be doing wiring. And what this does is it'll go in here and help you eject the terminal. So you slide it into this little keyhole right here, and you just push in a little bit, and it should help you release the terminal. Sometimes you have to push in, then push that, and then pull the terminal out. Alright, so I've got all my negatives in. I've got the fan relay and the fuel relay in. All I'm going to do now that I have everything wired up, is test the relays, make sure everything's going to work. So I'm going to trigger, and we should hear a click. Alright, that's good. That's that high amperage one. And we're going to do the same thing, trigger wire for that one. That's the fuel relay. So now, all I'm going to do is finish everything in, leave some pigtails on there, so that if he ever wants to add some relays to something, he can do that, or whoever might own this in the future. Alright, so I've got a 10 amp fuse in for the fuel, which should be more than enough, but I'm going to go ahead and clamp it and see what I'm getting, if it'll even register, because this really, it's around 20 amps or lower for that. Alright, so I'll try to put this where you can see right here, and all I'm doing is triggering the fuel relay, and I have a 10 amp fuse in there. I'm gonna go ahead and trigger it and see what it's drawing. Drawing 1.27 amps. Now, as the motor gets hot, the fuel pump, the motor that's in the fuel pump, as it gets hot, it's going to draw more amperage. But I'm seeing it's around 2 is probably where I'm going to end up at. So it really don't even need a 10 amp. I could probably get away with 5, but I'm just going to leave the 10 in there. And that way, if the pump wears or what have you, and it starts drawing a little bit more, at least if there's a short or it's bad, it should still pop the 10, but it's a little bit safer than a 5, I think, as far as not ending up broke down somewhere. But I'll make sure he has some spare fuses, and I'll make a diagram and everything for him. Alright, so now I'm going to do the same thing for the fan. I have the trigger set up, and I'm going to get a current reading. So it went up to 3.4, 3.1, and then it hovered around 8.18. So we know that we need at least a 3 amp on that, but I know from experience that we usually run a 30, because with those, I believe that's actually a brushless motor, but some fans have a brush motor, and it can actually vary quite a bit how much it pulls based off the temperature and other things. Alright, so it's all done, and I left some leads for the accessories. The two they're left over, and everything else is wired up. Now I'm gonna clean everything up, get everything zip tied, get it in there, get the ground bolted down and everything. Alright, so got it all wired up nice and neat. Got all the wires cleaned up. These are the extra for the relays. This is the ground that's going to go on the fastener, and it's going to go right in here like this. Now, I did notice in here we were missing our splash guard here, and the tire's right over here. So even though this has covers, it doesn't have gaskets. So what I want to do is seal this against the elements. Well, not so much seal this against it, but like, you know, cover that up so water can't get in there so easily. Your normal water that comes through here, it'll hit this and kind of shed off. You won't have any issues there, but you know, I really don't want to have any problems later with this. Alright, so we're officially done up front here. Got the battery tie down in. All this stuff is cleaned up. Everything buttoned up there. Then going back to here. Only thing I need to do later maybe is take that off of there.